Hello Year 10, welcome to today's lesson on Pythagoras Theorem. So we're looking at real life problems in a context. But before we do that, can you please write today's date and title, underline them both, and then have a go at the two starter tasks here. So find the hypotenuse, which you now know is the longer side, and then two questions on finding the shorter side. And if you could please round your answer to one decimal place where necessary. Lovely, please pause the video as you do this. Okay, good, so brilliant. So for the first one, you should have 16.6 centimetres. For the second one, 23.3 centimetres. For the next one here, find the shorter side. So remember it's the subtraction, so the square root of 19 squared, subtract 10 squared, gives us 16.2 centimetres, and then we have 16.5 centimetres. Okay, if you've struggled with those, it's really important you go back and look at the two Hegarty tasks set from last week, particularly if you didn't do them. I'm hoping most of you did by this point, but that'll really help you with your understanding. If you haven't done those yet, you're going to struggle today, so please make sure you go back and get those done if you need to. Okay, so we're going to look at our success criteria first. So bronze we've just done, which is recalling the rules of Pythagoras Theorem to find the longer side and a shorter side. Silver is to be able to apply Pythagoras Theorem to routine problems, so quite straightforward practical problems. And then gold is more complex problems. And we're going to go through these quite slowly together. It's not many questions, but we want to make sure we get the ones right that we're doing. Okay, so first things first. How can you use Pythagoras Theorem to solve practical problems? Well, you'll see in a moment there's loads of ways we can. And when you're solving a problem to do with Pythagoras where you're only given two lengths, there are certain steps you can follow to help you. So we talked about this last lesson a little bit. So number one, really important, is draw a diagram to help you. Okay, then look at the diagram and then again decide, are you finding a longer side or a shorter side, and label it X, and that helps you work out what you're actually being asked to do, because lots of this is just incorporating those two formula we've already learnt, but within a context. Okay, so let's have a little look. So we're going to do this one together. So it says, James places his ladder 12 feet away from the wall of his house. So here we go, 12 feet away. Leant against the wall, the ladder rests 16 feet high. So it reaches up the wall by 16 feet. What is the length of the ladder? Now, if you just read this without the diagram, you might be a little bit unsure as to what you meant to do. But you might also think, well, I don't want to be drawing a house and a proper ladder. You don't need to. You just could have drawn a triangle to show the problem. And then you realise, well, look, this is the length that we're looking for. Now, first thing we do is we select the appropriate formula. So we need to work out, is it a longer side question or a shorter side? Well, we now know from previous learning that the side opposite the right angle is the hypotenuse. Okay, we've gone over that quite a lot. So we know what we're doing is we're doing a longer side question. So we get the correct formula, which is that one there in the yellow. So c squared equals a squared plus b squared, or as we've talked about it before, you might see it written the other way around. So a squared plus b squared, and you have the equal c squared at the end, means the exact same thing. So first step, we now know is we substitute in the values that we have. So we know A and B are our shorter sides, so 12 and 16. Because addition, it doesn't matter which way round you put the 12 and 16 really, but we're doing 12 squared plus 16 squared equals c squared. Well, again, we know 12 squared is 144 and 16 squared is 256. If we add those together, we get 400, and then we find the square root of 400, because again, remember, this tells us what c squared is. We just want to know what c is. And just as a reminder, the opposite of square rooting is squaring, and vice versa. So we square root 400 and we get 20, so we now know that the length of that ladder is 20 feet. Okay, you may want to pause the video and copy it down, perhaps even with the actual question written, so you can see what we've done. You might then just choose to draw the triangle that's there, or if you're very arty, you might undo the whole diagram. You don't need to, but certainly get down the working out and the process. Okay, please pause the video as you do this. Right, lovely. So we should recognise actually it's just a basic long side question, this is. Okay, that's all it is, but in a context with ladders. Alright, so there are now two questions here for you to do. Think about what we did, draw the diagram, label the sides, label the side you're looking for, and it will tell you what sort of Pythagoras question you're doing. So please pause the video as you answer these two questions. Right, okay, good. So the first one, we've got a ladder 12 metres long, really important. Leans against a wall. The ladder reaches 10 metres up the wall. That's the height. A ladder is safe if the foot of the ladder is about 2.5 metres away from the wall. Is it safe? So what we're being told is, if this is at least or around about 2.5 metres away from there to there, that means the ladder's safe, and we're checking if it is, okay? So we know that we're trying to find this distance here. So we're looking for a shorter side, okay? And again, this is a sort of triangle you would draw if you were just given the information. We know it's a shorter side because we know that there is the right angle. Oh, pardon me. We know that's the right angle, so we know that that there, the 12, is the hypotenuse. So we're doing a subtraction. 12 squared subtract 10 squared equals a squared, or x as we've labelled it here. So 12 squared is 144, subtract 100, which is 10 squared, which leaves us with 44, and the square root of 44 is 6.6, but we then know that actually that ladder isn't safe, okay, because it's not around 2.5 metres away from the wall, so it isn't safe. Okay, so now a model football pitch is 2 metres long and 0.5 metres wide. How long is the diagonal? So we know that's 2 metres, we know that's 0.5. It wouldn't matter if you'd labelled these two sides or these two sides, a rectangle opposite sides are the same, but what we're trying to find here is what x is, the missing side, and it's the longer side because it's opposite our right angle, so we're doing our addition here. So 2 squared plus 0.5 squared. So remember, 0.5 times 0.5 is just a half times a half, so half of a half is 0.25. We add them together and we get 4.25, and then if we square root that we get 2.1, so it would make sense, it sounds right, for that to be 2.1 because we know the hypotenuse should be the longer side. Remember, it's a model football pitch, not an actual one, so that's what you should have, okay? Right, have a go at 2 more questions. So if you struggle with the first 2, we've just been through them together, have a look at these 2. You've got diagrams. It might help you to draw just the triangular part of the diagram of each one down in your book to help you. But please read the questions carefully and see if you can answer them. Okay, please pause the video as you do this. So, first one, some pedestrians want to get from point X on the road to point Y on another. The 2 roads meet at right angles, so you can see that here. Here's our right angle. Instead of following the roads, they decide to follow a footpath that goes directly from X to Y. So they're doing that instead. How much shorter is this route? Okay, so we know if this is the right angle, look, what we're looking for, we're looking for the hypotenuse. Okay, so we're looking for a longer side. So we're going to find out what that longer side is first. So 94 squared plus 33 squared equals c squared. So we're doing this calculation here, and then we square root and we get 99.6. So we now know that that distance there is 99.6 metres. But the question actually says, how much shorter is this route? So what we need to do is we need to go back and we need to add our 94 and we need to add our 33 to see how long the original route is. So if we do 94, add 33, we get 127 metres. And then we've got this new route, this shorter route that's 99.6. So you would do 127 subtract 99.6, and then what do you get? Well, you get 27.4, so it's that much shorter. But even if you don't get to that last bit here, you know how to find a missing side. This will get you marks and will get you points. Okay, right, so for 6, a mast on a sailboat is strengthened by a wire called a stay, as shown on the diagram. The mast is 10 metres tall, there we go, and the stay is 11 metres long, so there's our stay. How far is the base of the mast to the stay reach? Okay, so what we're looking for here is this. We're looking for that there. Okay, so we know we're looking for a shorter side because, again, opposite the right angle is the hypotenuse. We're not looking for that because we're given it, so it's a subtraction. So longest side subtract other smaller side. 11 squared subtract 10 squared is 121 minus 100. We square root 21 and we get 4.6. So x here is 4.6. We're happy with that. We've done our calculation carefully and it's shorter than the 11. 11 should be the longest side. Brilliant. Right, next one. So what do we do when not given a diagram? So a plane leaves Manchester Airport and heads due east. It flies 160 kilometres before turning due north. It then flies a further 280 kilometres and lands. What is the distance of the return flight if the plane flies straight back to Manchester Airport? What I would like you to do is try and, before we go through it together, try and draw a diagram to show this problem. Please pause the video as you do this. Right, well done. So let's have a look. So if we have, oops, there's our diagram that we might have done. So we start here, Manchester, 160 kilometres east and 280 north. What is the distance of the return flight if we went straight back? So this distance here. Okay, so we know it's a long side question because look, we're opposite our right angle. So again, we always know, and I know you're probably sick of me saying it, but I'm going to keep doing it so we remember. We know that's the hypotenuse, so it's a longer side question. So we would do our 160 squared, okay, plus our 280 squared, which is here, and then we would square root and we would get 322 kilometres to 3 significant figures. Now, it's 3 significant figures because that's the answer you actually get. If you work this out on your calculator, if you square root 104,000, we get this answer and lots of decimals afterwards. Now, I want to round to 3 significant figures. Well, we've got our first significant figure, our second and our third. So the 4 is in charge. And we know the rules of rounding are 4, leave it alone, 5, round up. Well, 4 doesn't round the 2 up, so it stays as a 2. So we get 322 kilometres. Okay? Therefore, the distance of the return flight of this here is 322 kilometres. Again, it should be the longest side because it's the hypotenuse, and it is. Right, have a go at these 2 questions here. Pause the video as you do it. I've given you some advice, so sketch a diagram to represent each question, or questions, plural, and show all working out. Please pause the video as you do this. Right, good. So question 3, how long is the diagonal of a square with a side of 8 metres? First thing you should do is what's the key words. So if you go back, have a look at what's gone into bold here. So we've got diagonal, okay, we've got square, and we've got side of 8 metres. That's really important information because we know we have a square with a side of 8, which means all the sides are 8, and you're being asked, how long is this diagonal? Okay, what is it? So first things first, what sort of question is it? Well, you guessed, we're opposite the right angle, so it's the hypotenuse. So we know we're doing a squared plus b squared equals c squared. So we've got 8 squared plus 8 squared is c squared, which is 8 squared equals, we should know by this point, although I'm making an assumption, we should know from prior learning that 8 squared means 8 times 8, okay, which means 64. So we're doing 64 plus 64 is 128, square root it, and you get 11.3 metres rounded to 1 decimal place. And again, we should be happy with that being 11.3 because look, it should be longer than the 8 and the 8 because it's the hypotenuse, the longest side, and it is. Okay, lovely. Right, second one, bold, some really important information appears. So again, draw a diagram. A ship leaves a port and sails 15 kilometres east. There he goes. It then turns and sails 12 kilometres north to a lighthouse. Well, there we go. The journey takes 1 hour. How much time would be saved by travelling directly to the lighthouse, and assume the trip travels at the same speed? Now, this is the sort of question students look at and go, oh, it's to do with time, I don't know. But we do know from looking that what it wants to know is, how long is that first and foremost? So we know it's a Pythagoras question to start with, and we know how to find the longer side, and we know it's a longer side because we've gone due east and due north. So this here is our longer side. So let's deal with that first. We know we're doing a longer side, so we've got 15 squared plus 12 squared, and there's our addition. We get 369. Square root of 369 is 19.2 kilometres, although you get a longer number than that, I think it's 19.2 something. In fact, I'll just check whilst we're doing it. You get 19.209 ... Don't delete that, leave it on your calculator, because now we've got to find out the amount of time it takes. Now we know, let's go back to this here, we know an hour is equivalent to 60 mins. Okay, so we need to find what 19.2 kilometres is as a proportion of 27, which is the 15 and the 17. So we've done this before in fractions. Okay, finding one thing as a proportion as another, particularly when we've been finding it as a percentage, but here we're not, we're doing it in time. So also when we looked at compound measure, we use this process. So you do your value, so just put answer and then divide by 27. And then the reason we times by 60 is because we want to convert that proportion into time. Okay, and actually therefore the journey takes 42.7 minutes, which of course if we were rounding, we would round up to 43 minutes. So if the first journey, which is this route here, takes an hour and this one takes 43 minutes, that's a difference of 17-ish minutes. Now, I would expect you all to get this bit, the Pythagoras part. Now this bit may be tougher because we've not looked at things like this in a little while, but again, this is where it's important and things link in. We did this a lot when we were doing percentages. Right, one quantity is a percentage of another. Now we're writing one time over another, and we're trying to find out the difference. Okay, right, have a go at this one please. It's an investigative problem. Just have a little look at it. Sketch a diagram to represent each question, show all working out. So please pause the video as you do this. Right, good. So let's look at our sketched diagram first. Hopefully you've just done that bit so far. Don't worry if you've gone ahead. So a ladder is 4 meters long. There we go. There's our ladder, 4 meters long. It is put up against a wall. Brilliant. Now you're told here the foot of the ladder is 1 meter away from the wall. So we've now got these two values here. How far up the wall will it reach? So we're looking for this distance. So this time this is our x. Now we know that the floor and a wall meet at a right angle. So we know that's the hypotenuse. So we're doing a shorter side question. So we're doing this. So we're doing 4 squared subtract 1 squared. So 16 subtract 1 is 15. And the square root of 15 is 3.9 meters. So that's how tall the wall is. Then you're told the ladder is moved and now reaches 3.6 meters up the wall. So now you're given this information. And in fact, I think we change it. Good. You're given 3.6, and then it's how far is the foot of the ladder away from the wall? Because that's now higher, or sorry, is it higher? Yeah, it's a little bit higher, or a little bit lower, sorry, it was 3.9. Now that it's fallen lower, the angle of the ladder will have changed, so the distance between the foot of the wall and the foot of the ladder will have changed. Well, again, that's the hypotenuse, isn't it? So we're still looking for a shorter side, so we're still using the same formula. 4 squared subtract 3.6 squared, so that's your calculation, and it's 1.7 meters. So just a slight change in height has quite a big effect on the distance here. Okay, well done. Right, please pause the video and have a go at this question for me. This refers back to the very first lesson we did last week on Pythagoras Theorem. Good, let's go through it. So it's a test. Is the triangle with sides 7, 24 and 25 a right angled triangle? Give a reason. So we know we're referring to this formula. That's what we use when we're checking, when we're given all of the dimensions of the triangle, which we are here, look. We're checking, does it make a right angle? We can't say it looks like it, so it does. We have to check. So we know we're doing 24 squared plus 7 squared, because we've got to assume that's the hypotenuse because it's the longest side. So we're adding the squares of these two values to see if it equals 25 squared. Well, let's see. If we do 24 squared, which is obviously 24 times 24, we get 576. And if we do 7 times 7, we get 49. And if we add those two values together, we get 625. Now, unless you know your square numbers up to 25 squared, you will think, well, I don't know if 625 is the same as 25 squared. So let's square root 625, and it does. It does equal 25, which means that yes, that triangle is in fact, and let's put it in for good measure, a right angle. Brilliant. Okay, now I'm not setting you a Hegarty task for this because there isn't one that really fits it well without going to other things we've not done yet. So to evidence the work done in this lesson, please upload a photograph of your work to the submission folder that you've done for this. So Hegarty for the previous lesson, a photograph for this one, and be sure to submit it to the correct group. So just check which group you're in and look for your teacher's name. Make sure you do it, otherwise my eyes will turn to fire like Captain Marvel. Okay, very well done, Year 10, absolute pleasure, and I will see you next week.